Thomas Paine Iron Bridge. The Thomas Paine Iron Bridge was a new and innovative bridge design crafted by Thomas Paine in 1786. The same Thomas Paine who wrote Common Sense, a pamphlet encouraging the colonists to break away from British rule. Thomas Paine noticed how in America there were many major cities. Philadelphia specifically was flourishing and thriving as a port city. This is a map of the Pennsylvania area during the 18th century. However, the seasonal dangers of the river dividing the region became an obstacle to the city's growth. Thomas Paine wanted to find a way to connect the country farms and their port on the Delaware River. He wanted to create a structure that could withstand water, ice, and wind. Thomas believed a bridge was the perfect solution to connecting a geographically fragmented republic. The sketch shown here illustrates Thomas Paine's design. The design took Thomas Paine a decade to finalize, and in these 10 years he took a different path than many other revolutionaries. Most builders during this time period would create their projects solely off their own education and experience. However, Thomas Paine used other popular figures during the time, including Benjamin Franklin, George Washington, and Jefferson, as patrons. Additionally, he opened up the bridge design to the public so the people could critique and make suggestions. What made Thomas Paine's bridge so differently than others was that it was the first proposed design with the primary material being cast iron for a single-span bridge, differing from other bridges in the time period which were built with stone and wood. The use of iron was revolutionary because iron was very strong but still lightweight and easy to work with. Also, the design of the bridge was new for the time period. Thomas Paine designed the bridge with a curved arch made from several iron segments. The interlocking ribs could evenly distribute weight and reduce stress, unlike stone, which was a heavier material. This bridge in the picture accurately depicts the design of Thomas Paine's bridge. He used mathematics and physics to calculate forces like compression and tension to further improve his plan. This approach to a new design made building the bridge easier and safer to use. In the short term, the bridge design had minimal impact on the American economy because it was never fully built in the United States. The first iron bridge shown on this slide wasn't built until 1838. It was called the Dunlap's Creek Bridge in Brownsville, Pennsylvania. Therefore, it didn't immediately improve transportation or trade in America. Similarly to the economy, the iron bridge had a little impact on society in the short term, but the iron bridge did represent hope for a new nation because it showed that America could also have a significant role in science and technology. On the other hand, the iron bridge had a significant impact on the American economy in the long term. The design helped the growth of the iron and steel industry, since both of these industries were necessary to keep up with the demand for the primary material. Also, the bridge model inspired other stronger bridges, railroads, and factories, making transportation faster and cheaper. This aided in expanding commerce, connecting relations across the ocean, and supporting the new nation of America. Overall, in the long term, economically, the Thomas Paine bridge design inspired other projects, boosting industry trade, going hand in hand with economic growth. Additionally, the bridge design heavily impacted society in the long run. The new and innovative plan inspired other builders and future generations to utilize math and science, as well as think creatively when it comes to building bridges or any other infrastructure. The bridge and its shift in material also helped spark the Industrial Revolution, because it suggested the use of iron and steel, which required efficient and stable manufacturing processes. Overall, Thomas Paine's innovation for the iron bridge design became the model for bridge construction. This helped spread the word about an engineering revolution to come.